Hello, I am David W. Parker. This is Programming Today I Learned, WebGL series, episode 45. Today we're going to be looking at multi-attributes, which is when we have a set of buffer data that shares multiple attribute data to it simultaneously. It sounds kind of confusing, and it is a little bit at first, but think of it as buffer data where you can send in the point and color information simultaneously together as opposed to having two different buffer datas for one for each. And what that's going to take to do that is two things called offset and stride. Offset is how many total items are there and times the byte size does the point represent. So basically, if you think of a point and you think of the colors, a point can be X, Y, Z, W, and a color can be RGB alpha. That'll be 8. So there'll be 8 per item. And then the stride, that'll be the stride, and then the offset will be how many items are there for the first item to the second, meaning color to the color will be displayed after the first 4 bytes, which represent the X, Y, Z, W location. So it's a little confusing at first without looking at code, so let's go ahead and get down into the dirty details. We have the same animation thing as before. It's been a little more cleaned up, but other than that, all the code is the same in terms of the actual animations. First thing to have changed here is under render buffers, you'll see that we no longer have the buffer data specified for this, and instead we have this new 2 lines that used to be 0 for each. One that is the points f size, which I'll explain in a moment, times the stride, and then so this is the stride value, and then the next one is the points f size times arrays j offset, and we'll look at what that is as well. You scroll down here, you can see here's our new float32 array, and so you can see it has all of the points and the color values in it. For each line we have 4 values that represent the point, and then we have 4 values which represent the colors. In this particular instance, you'll see our A position and A color is still just going to be represented by 2 and 3 respectively. So we're only using these 2 values and these 3 values respectively. The reason we need to have the extra values in this float array is otherwise WebGL is going to throw an error when the stride values don't end up matching being multiples of 4. So that's something to be aware of. So we're going to go ahead and set the stride to 8 because we know that each line has 8 items on it. So that's what the stride comes into place. You can know that your n is going to be the number of points divided by the stride, so there'll be 3 still to compute the n. And you'll see here's the offset. We have 0 offset, so there's nothing in before points. And then after 4 items, 1, 2, 3, 4, that's when color starts. So you can see color is the next 4. So you could see that the offset given here is 4 times the f size, and for here, the stride is the stride times the f size. And the f size is this interesting constant that float32 gives us, which is bytes per element. So you could actually just use bytes per element instead of f size, but we're just using f size here as representing this float array size. So it's just an easier way to write it rather than writing out this whole long thing every single time. So, and then we have render buffers, which takes in the array as well as the set of points. Everything else is the same, so we don't need to look at that. And you can see here's our application just as before. It has all the same details, but all the data for the color and the points are all stored in this one array, which simplifies things and makes things a lot more efficient since we're not allocating a lot more memory for different buffer data and float32 arrays and all those kind of things. So that's it for this episode. If you liked what you saw, go ahead and subscribe, like this video, share it on social media if you will, and go to ProgrammingTIL.com and sign up for my newsletter. Have a great one.